There's this hidden blueprint that brings a quiet order to our digital world. It's something you use all the time, but you probably never even see it. It's the elegant answer to a huge problem in computing, and it's called a document type definition, or DTD for short. Just think about it for a second. How does your web browser know how to display a web page correctly? Or how can two totally different business systems share information and understand it perfectly? There's gotta be a set of rules, right? An agreement on how that information is supposed to be structured. And that's really the problem we're going to explore. So, to really get why this matters, let's just imagine a world without these rules. It was a time of digital chaos, really, where sharing something as simple as a file was, well, anything but simple. This really gets to the heart of the problem in the early days of computing. Back in the 70s, companies were starting to collect huge amounts of digital data. The big catch, though, was that data made in one program was basically useless in another. Every single application spoke its own private language, creating these little digital islands of information that just couldn't talk to each other. And this wasn't just some small annoyance. It was a massive roadblock. Imagine having critical information trapped in a format that could just disappear if the software went away. People realized they desperately needed some kind of universal translator, a common set of rules for how to structure data. And so out of all that chaos came this really brilliant organizing idea, a way to create a formal blueprint for what a document should look like, to make sure everyone was reading from the same sheet of music. And here it is, the document type definition. And a DTD is pretty much exactly what it sounds like. It's a formal declaration that spells out all the rules for a certain type of document. It defines the allowed pieces, the order they have to be in, their relationships. It's basically creating a grammar for the document. Now, to see where DTDs really shine, it helps to know the difference between HTML and XML. See, HTML is all about presentation, making text bold, putting an image here or there. But XML doesn't care about how data looks, it cares about what data is. It's all about describing the data itself with meaningful tags. And that focus on pure structure is what makes a blueprint like a DTD so incredibly powerful. So, what's actually in this DTD blueprint? What does it define? Let's break down the main parts. First up, you have elements. The easiest way to think of these is as the nouns of your document. They're the main containers for all your information. So if you're making a contact list, your elements might be name, company, and phone. They're just the fundamental building blocks. Then you have attributes, and these just give you extra details about the elements. So if contact is an element, an attribute could be something like type, where the value is either work or personal. Attributes just add a little more context to each of those building blocks. And this is where it all comes together. This single line from a DTD is a really powerful rule. First, it says, okay, we're going to have an element called address. But here's the important part. It then dictates the structure inside that element. It says that an address must have a name, followed by a company, followed by a phone, not in a different order, and none of them can be missing. This is the blueprint in action, plain and simple. So once you have a blueprint, you can do something incredibly useful. You can inspect the final product to make sure it was built right. In the digital world, we call this validation. This brings us to a really important distinction. An XML document can be well-formed. That just means it follows the basic grammar of the language, like every opening tag has a matching closing tag. But a valid document, that's a whole other level. It's not just well-formed, it also perfectly follows every single rule laid out in its DTD. It's been checked against the blueprint, and it passed the inspection. And this ability to automatically check data is the real superpower. A program can use a DTD to check information it receives before it even tries to do anything with it. If the data doesn't match the blueprint, it gets rejected on the spot. This prevents all kinds of errors and just makes everything more reliable. It's like a quality control check for pure information. Now, like any technology, DTDs have evolved over time. And while you might not see them as often today, the core principle they established is, honestly, more important than ever. DTDs were a huge leap forward, but they weren't perfect. For one thing, they couldn't specify what kind of data should be in an element. Was it a number, a date, or just some text? Plus, the syntax for writing a DTD wasn't XML, so you had to learn another language. And these limitations really paved the way for what came next. The successor to the DTD is something called XML schema, and it fixed these key issues. First off, it's actually written in XML, so the syntax is familiar. But the biggest deal is that it supports specific data types. This means you can say that a price element has to be a decimal number or that a quantity has to be a whole number. This allows for much, much more precise and powerful checks. And that is the real takeaway here. While you're probably more likely to run into XML schema today, the core idea, this revolutionary concept of creating a clear, verifiable blueprint for data, that was all pioneered by the DTD. That principle is the foundation of how we reliably share data across the internet. It kind of leaves us with a peaceful thought. The DTD is such a perfect example of the invisible architecture that makes our digital lives work. And it makes you wonder, what other hidden rules and quiet agreements are working in the background, turning all that potential chaos into the connected, orderly world we just take for granted every day?